Okay, um, this equation that Newton found for universal gravitation works very nice, but there is a problem. So the problem is that it doesn't explain how the masses recognize each other and apply forces to each other. Because in order for the, and so we had many questions like, do these forces happen um, automatically, like in no time? We know that there's no such thing as um, in infinitely big velocity. We know that the speed can be up to the speed of light. So that means that these two forces cannot just happen automatically. And how do the masses recognize each other? And how do they know how big they are and how far they are? So we had questions to answer. We haven't answered them yet. We have different theories. So the older one is the field theory. All right. So the field theory says that every mass creates around it an area. And this area has somehow the information of the mass being at the center of it. So every mass carries its own information, gives the information to the area around it. Think of like a bubble around every mass. So when two masses come together, the one enters the bubble of the other. And they get the information of each other through their bubbles. So this is the idea of the gravitational field. This bubble around any mass is the so-called gravitational field. Now, so as let's say we have a mass here and it has its own gravitational field. So when another mass enters carrying its own gravitational field, they learn about the existence of each other and then they apply the forces. So when we are close to the Earth, we consider that we are in the Earth's gravitational field. Okay. How big it is? Well, we consider that for as long as there are forces, there is gravitational field. It means that every mass's field is extended until infinitely big distances, and where the field is so small that can be considered as negligible, just like the forces. All right? So we are on Earth's gravitational field, okay? If we go to a different planet, we will feel that planet's gravitational field and so forth. Now, we do know that the forces create acceleration, right? And the acceleration that the forces create, especially the forces of gravity, we already talked about the force of gravity creating an acceleration, which on Earth is the acceleration due to gravity g, which is 9.8 meters per second squared. So we actually have these formulas that give us the same thing. If I take this formula, use the mass of the Earth, my mass, and the radius of the Earth, I will find the same value that I will find if I just multiply my mass with 9.8. All right? And it's because these two formulas are the same, and the g, the acceleration due to gravity, is actually given by this formula. So we found that any planet that has a mass m at a distance r from the center of its at the distance r from its center, there is acceleration. The forces, the objects are pulled with a certain acceleration, and if we use this for planet Earth, we will find 9.8 meters per second squared, and it will be meters per second squared. Now, for some other planet, the acceleration due to gravity will be different because we have a different mass, a different size of the planet, so G will be different. Meaning that if something falls, where something falls on Earth, it falls on a certain way, it accelerates in a certain way, and with an acceleration of 9.8 meters per second squared. On a planet that has a bigger mass, it will fall with a bigger acceleration, or on a smaller planet will fall with a smaller acceleration, right? Well, the radius matters too. So if we go to a planet and we see that things accelerate higher, we say, oh man, this planet creates strong gravitational forces, okay? And so the gravitational field it creates is strong. Well, if we go to a planet where the objects accelerate in a smaller rate, that means that the forces, therefore the acceleration is not that strong, it's weaker. So we say, oh, right, so this planet creates a weaker gravitational field and a weaker, smaller acceleration due to gravity. So the acceleration due to gravity has one more name. It's called the field strength. Gravitational strength, gravitational field strength, okay? Because the acceleration due to gravity, acceleration that the objects fall with, shows us how strong the forces this planet manages to create. Now, this acceleration due to gravity, we see that it doesn't depend on our mass. It depends only on the mass of the planet.